Okay, hello everyone, a very good afternoon. So today my project is credit card fraud detection. For this I have taken the dataset of the credit card.csv, which you can see here. So this is the dataset which consists of the null values and missing values, and the data is somewhat sparse and it is the real-time data. So we need to pre-process it before we take this data to train our model. So see here, there are total 31 columns, and the names of the columns like time, V1, V2, V3. Actually, it is the data which is taken from the bank. So they have maintained some security issues. That's the reason they changed the actual column names and replace it with some random name like V1, V2, V3. So the user or the other person don't know what the actual encrypted message present in this particular word. So there are total V28, so 28 characters and amount, where so to which amount do the user is asking the loan, and class is nothing but yes or no. So it is the problem which is a supervised learning, like it having a target class, a labeled class, so that we can train our model with all this data and taking remaining rows or like an independent features and taking the column as the target feature, and with this we can train our model. For that reason I have chosen this logistic regression. So logistic regression is a supervised learning algorithm where you can see I have run this particular thing in the Google Colab. Before that, okay, it has loaded successfully. So why I chosen the logistic regression is logistic regression is also called as sigmoid function, which ranges in between 0 to 1. 0 is nothing but fraud and 1 is nothing but it is genuine transaction. That's the reason I taken the logistic regression, which is present in the scalar.linear model. And after, not only I not stopped with the logistic regression, I try my model with the decision tree classifier as well. So decision tree classifier is also a very good algorithm, but the main disadvantage is it having more variance. So that to reduce that variance, I use this random forest classifier, which follows a bagging algorithm which combined multiple decision trees in order to predict the single output. So this random forest gives a good accuracy when compared to this logistic regression and decision tree. I have already run this particular thing, so you can see it visually as well with the help of the Seaborn and Matplotlib. So I loaded this dataset which is present in this dataset folder creditcard.csv, and then firstly we need to collect the data. So data collection step is completed, and second we need to understand the data, what number of columns there, how we need to handle that. So as I discussed at the starting of that explanation, like it has 30 columns. So starting from the 0, so it has 31 columns because 0 to 30 indexing, so 31 columns, and total number of rows is you can see the data type of each column, it is the float 64, and you can also see the total number of null values present in this, and this dataset consists of duplicates as well. So describe and info, these is the methods which we will use in order to understand about this data, and shape which will give this 28,000 2,84,807 rows are present and 31 columns are present. So in order to get only the names of the row, you can also use this command called df.columns, and size is gonna to multiply both the x as well as y value and present the total number of values present in this, in order to check whether there is a null value present in any column or not. So some will give the summary, like it will give the count. Uh, so do it consist of any null value or not. So firstly I had run that particular thing, then I get some duplicate values in this v28 and v26 7. So then I run this particular thing, so again I run that. That's the reason it's showing of 0 0. So duplicated dot sum, so it will use it to give this many duplicated rows are present. So in order to remove, use the drop underscore duplicate function. After performing this drop underscore duplicates, before that we need to check for assurance, like whether this dataset consists of any duplicate values or not. That's the reason this duplicated method is used. So some use it to give the total number present, and drop duplicates use it to remove the duplicates, and describe, it will describe the mean, standard deviation, variance. Like variance, it is the average of the squaring of the distance from the mean, and value dot count, which gives the value of the each category present in a column. Like in the class category, it has 0 and the 1, where the 0 is taken as genuine and 1 is taken as fraud. So genuine cases is more when compared to the false cases. So we need to do normalize, because our model will think like all the examples which is training majority is the genuine, so every transaction is a genuine, but it is the false negative. That's the reason we need to normalize this. We need to make each feature is contributing equally for the prediction of the target. For that reason, I use it this normalize is equal to true, so that it can convert it into the decimals. That's the reason there is no influence. For example, there is 28,400, which is major. Definitely this genuine class is more far than this particular thing, so it has more contribution for the prediction of the model, like that the model thinks, so that it is we will not make any variations like this. That's the reason I did the normalize. And for showing you, this is the class distribution, which is nothing but the bar chart count plot. This is the count plot, and you can see here where 1 is for the fraud, and the genuine transaction is for the 0. So describe user to give the mathematical thing of this, and this is the box plot which you can see here, and this is the transaction of the histogram between the time and the count of this, and the heat map user to show the correlation between all of this. And let we quickly go to the model. So here the logistic regression model. So the logistic regression which is present in the linear model from Scikit-learn library module. So I have taken the nickname as logistic model, and then training of the model with x time, y time. Earlier we have split this using the model underscore selection, and then predicting this value. So predict x comma test, it gonna to predict some value. So in order to check whether it corrected right or not, I used some metrics like the precision score as well as accuracy score, confusion matrix. Here you can see confusion matrix recall F1 score is the combination of both recall and precision. So here you can see it giving the accuracy of 99%. So it's considered very good model. Why means in our dataset major columns, major rows are a genuine cases, so that it will perfectly saying it is a genuine. Even for the fraud also it may say genuine, means the model think that's only correct. That's the reason it's showing this much of accuracy, where the precision is nothing but false positive. How many false positive means 0 positive, means that is actually negative, but the model predicted has the positive, so that's precision. And recall shows a 66%, and F1 score is the combination of both this, and the linear area under the curve shows this. So for the visual representation, this is the confusion matrix, which will help us in order to identify the actual versus the predicted, and this is true positive, and this is true negative, false negative, false positive. Coming to the classification report, it will give a quick overview of what happens here, and decision tree which will taken from the Scikit-learn.tree module. I have taken the criterion like a guinea, because it will decide which particular column need to take as the root node based on this guinea or information gain. If we not mention any criterion, then it automatically taken the guinea by default, and I chosen the random state of 42 for the generating the results accurately whenever we run this. Then I trained this particular model and predicted this, and after predicting I will calculate this accuracy metrics, and after calculating plotted the confusion matrix for this, and did the classification report for the X test and Y test, and finally the random forest. Before that we haven't estimated the values of for this accuracy, right? Earlier it gets 0.7, so it gets some precision, and recall is 0.66 for the decision tree, and now it is 0.7. So at the end I have make a clear comparison of all those models. So taking the variance reducer random forest classified from the ensemble because it follows the bagging algorithm. So random forest classified where the n estimators is 100. It's required to keep the n estimators and then train that model, fit that model and finding the accuracy. So it's showing a precision of 0.97, which is in high. Generally the precision is high means the model trained well, and the recall should be of low, then the model will train well, like that we can say, based on the precision and based on the. So here you can see all the three models and making the comparison by using the metrics like accuracy, precision, recall, f1 as well as radian under the curve. Here you can see the accuracy when compared to the all three, the accuracy is more for the random forest, and next more is for this particular decision tree, and next more for the logistic regression. And coming to the precision, this having the highest precision, and this having next highest, and this having the third highest. When it comes to the recall, so random forest, it will having the best recall value, and f1 score should be of the maximum. So this is the maximum, and this is also should be of the maximum, so that it will we will by defaultly based upon the predictions, we can blindly use the random forest for training and giving the better results, right? So that I trained that model. After training, I saved that particular model in the saved module. Actually I did in the Google Colab, because that is not supported by the VS Code. You can also do this particular thing in the Jupyter notebook as well. But going to the Google Colab is better than savior version. No need to install anything, just using the source of the Google. And next it comes to, after downloading, I had uploaded those files in the saved models. Here you can see the best model and time scaler, because we have scaled the time and the amount column which is present in the dataset. And now it comes the front end part. In order to represent our model to available for the user, we need to mention a front end application. Further, the CSS, this is the CSS cascading style sheet for applying the colors and styles for it, and index.html, where it will take the input like class is equal to footer powered by random forest machine learning. So it will give the values on the website. So this is the columns which they're kept. We need to enter the values, based on that it's gonna to predict, and this is the actual logic which is present behind that front end application. And the readme, you can see this is my readme. And when coming to running, so first we need to go this particular folder. I saved this in AIML GenAI track project template. After that, in that it is fifth project development phase, and going to that, already I run this by running the command of python app.py. You can run this particular thing. So why I'm scrolling up is to see you the output what you get from this. mm, mm. So this is the output what we will get from that. It will having the v1 to v28 columns, and this is the amount what is there. Then we need to predict this output, so we need to enter this value. You can enter any value, so it will give you the actual prediction. After actual prediction, you will get whether it is a true genuine prediction transaction or a fraud transaction. And you can see my project report, where you can see the entire project problem ideate phase with the problem statement. It's having a bank loan or credit card approval officer, and you can see my empathy map, and this is my brainstorm. So what is the step-by-step ideas in order to solve this problem, and this is custom journey map, customer journey map. So what type of solution do it actually require? So user requirement, functional queries and non-functional queries and system queries, and its data flow diagram, how the data is a flow from one to other, like everything which I have detailedly mentioned in this particular thing. And last I have included, so I said you right, when you enter some values like this, like any value, you can get the values like genuine transaction, and for entering the value and keeping some amount like 0, then you will get that like a fraud transaction. So this is the commands which we are running, and this is finally my process structure. So this is all about my process. Thank you.